In this episode, we're going to look at configuring point-to-point single area OSPF version 2. I'll show you how to do it, and we'll talk about the concepts along the way. We'll activate OSPF routing using network statements and wildcard masks, configuring OSPF routing on interfaces, and by using network statements quad 0 masks. In addition, we'll configure explicit router IDs and passive interfaces. We'll be discussing configuring router IDs, configuring networks for OSPF routing, configuring passive interfaces, and finally verifying OSPF configuration. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Point-to-point single area OSPF version 2 configuration. I have the Packet Tracer Lab opened up here. On the left side, I have our work area. We have our topology and our devices. We're going to do our configurations. On the right side, I have our instructions. The way bottom right is the window that opens up when you open up your Packet Tracer file. On the top right, I have the Word document of those same instructions. The reason I'm using the Word document here is there's some questions we have to answer. Using the Word document allows me to type my answers in and save my Word document. Looking at our topology, we have 3 routers that are the core of our network. They're connected up with WAN connections. They all have /30 networks associated with them. And then off of each one of those routers comes a local area network. It has a layer 3 switch and a PC that'll allow us to have connectivity throughout our entire network. Here's our addressing table. We can see that we're only using IP version 4. So we have our devices, the interfaces on those devices, what the IP addresses are, and then the subnet mask. We have our objectives, we have our background, down to our instructions. Part 1, configure router IDs. A, start the OSPF routing process on all 3 routers. Use process ID. We have to go around each router and enter in this command, router OSPF and a process ID of 10. I'm going to go ahead, click on router 1 here. I make my router 1 window a little bit bigger, going right to left. Formats everything a little bit better. Type enable to get into privilege exec mode. Type config T. That's where we have to enter in our router OSPF command. From here, we can then type in router space OSPF, and then we have to tell it what the process ID is. We're going to use 10. So router OSPF 10. And then we have to go around to every other router. So I'm going to minimize our 1 router, open up our 2, make that window a little bit bigger, going right to left, log in, type enable, config T, and then router space OSPF 10. That enabled OSPF routing on R2. Minimize that window, open up R3, make it a little bit bigger, going right to left, log in, enable, config T, and then router OSPF 10. And enabled routing for OSPF on R3. On to part 1, step B. Use the router ID command to set the OSPF IDs of the 3 routers as follows. R1 gets the router ID of 1.1.1.1, router 2, 2.2.2.2, and router 3 is 3.3.3.3. Okay, I'm going to start on R1. Since we are still with the router OSPF 10 where our process ID is 10, I can just go ahead and enter in our router ID. So it is router-ID, and then what we want our router ID to be, 1.1.1.1. And then I'm going to jump over to R2, router-ID, and then 2.2. Whoops. Spelled 2 dot wrong. 2.2.2.2. sets that IP router ID. And then going on to R3, router dash ID, and then 3.3.3.3. Takes care of part 1. On to part 2 of our instructions. Part 2, configure networks for OSPF routing. Looks like we have several questions before we start. How many statements are required to configure OSPF to route all 3 networks attached to router 1? Looking at router 1, we have 3 connections. We have 3 networks connected there. Each one of those networks require a network statement. And so to answer this question, how many statements are required to configure OSPF to route all 3 networks attached to R1? There are 3 statements, because there are 3 networks. 3 statements. Each network requires its own network statement. Next question. The LAN attached to R1 has a /24 mask. What is the equivalent of this mask in dotted decimal representation? What is a /24 in decimal? Well, that's 24 ones followed by 8 zeros. You can divide those 24 ones into octets, and that'll give you 8 ones, 8 ones, 8 ones, followed by a 0. 8 ones is equal to 255, so that gives us 255.255.255.0. Okay, typing in our answer, 255.255.255.0. Next question. Subtract the dotted decimal subnet mask from 255.255.255.255. What is the result? So take 255.255.255.255, quad 255s, and then subtract our /24, which was 3 255s. So if I subtract the quad 255s from the triple 255s, that'll give me a 0, a 0, a 0, because each one of those octets, the first octet had a 255 minus 255, second octet had a 255 minus 255, third octet had a 255 minus 255, the fourth octet had a 255 minus the 0 from the /24 subnet, so that it will equal 255. What is the dotted decimal equivalent of a /30 subnet? A /30 subnet, dotted decimals. So we start off, we got 24 ones. So that gives us 255, 255, 255. That's 3 255s. For a /30, that means we have 6 bits left over. And when we convert that 6 bits followed by 2 zeros into a decimal number, we add up 128 plus 64 plus 32 plus 16 plus 8 plus 4 gives us 252. 252. The final answer here is 255, 255, 255.252. Last question. Subtract the dotted decimal representation of the /30 mask from quad 255s. What is the result? What they're having us figure out here is the wildcard mask. We're going to subtract that /30 subnet in dotted decimal notation from quad 255s. First 3 octets are 255 minus 255. That gives us 3 zeros, so 0.0.0. And then we got 255 minus 252. So 255 minus 252, that gives us 3. Our final answer is 0.0.0.3. That gives us a wildcard mask for that /30 subnet mask. On to part 2, step 1A. Configure the routing process on R1 with the network statements and wildcard masks that are required to activate OSPF router for all attached networks. The network statement values should be the network or subnet mask addresses of the configured networks. Here's an example of that, or here's the syntax. And so we start off, once we're in that OSPF configuration, we have the word network, then we put our network address in here, then the wildcard mask, then the keyword area and our area ID. Now, best practices say for a single area OSPF, which we're configuring, our area ID should be 0. You can use any number, but best practices say go ahead, use 0. We're going to make sure we do that. Now all we have to do is just the 3 network statements on R1 to put in our network addresses and our wildcard mask. So I'm going to scroll up here to our addressing table. Here's R1 with its information. /24/30. Good thing they had us figure that out for our wildcard masks. I'm going to go ahead, click on R1 here. We are still in the routing protocol configuration. Router OSPF10 we entered, then we set the router ID as 1.1.1.1. Now we can put our network statements in there. And our network statements start off with the keyword network once again, space, the network address. And so the network address for the first network, 192.168.10.1 with a /24 is the 3 octet. So 192.168.10.0. We can go ahead and type that in, 192.168.10.0. Then you have to put the wildcard mask in. That's the inverse of the subnet mask. Subnet mask here is 255.255.255.0. So you switch all the ones and the zeros. That will give us 0.0.0.255. We just figured that out a couple minutes ago. Now we say, what area do we belong to? So we put the keyword area and then 0. Like I said, best practice is to use area 0 in a single area OSPF. You have to add the third network. The third network right here for serial 010, 10.1.1.1.1 with a /30. Well, this isn't the network address, this is the IP address. Network address is actually one less than this, so 10.1.1.0. Starting off with our network statement for this one, so it's network space 10.1.1.0. Then we have to put in our wildcard mask for a /30. If we scroll down here, right here, they had us figure that out. This is the wildcard mask for a /30, 0.0.0.30. We can go ahead and enter that in, 0.0.0.30. And then the last part here is what area is that interface going to belong to? Once again, we're doing a single area OSPF, so it's area space 0. Invalid. Oh, look at that. I have a typo error. Now, once again, this is traditional Cisco iOS operating system. No news is good news. You screw up, they're going to tell you something is wrong. Right here, it says OSPF, invalid address mask combination. When I typed in the network address, I did that correctly, but when I typed in the wildcard mask, I added an extra 0. It should be .3 at the end. Instead, I put .30, so let me know. What I can do to fix that is quickly up arrow, left arrow over, get rid of that 0, and then just hit enter. Notice, no news is good news. I did everything correctly. I entered the command in. Cisco was happy with it and didn't tell me. Last network we have to go with is this one right here. The network address is 10.1.1.4. .5 is the first IP address. .4 is the network address. We can go ahead and type that in. So it's network space 10.1.1.4. And then the wildcard mask is the same one as we just entered right above us, 0.0.0.3 and area 0. Those are the 3 networks on R1. Scrolling down to our directions. Verify that the OSPF has been configured properly on R1 with network statements and wildcard masks that are required to activate OSPF routing for all attached networks. The network statement value should be the network or subnet addresses of the configured networks. Okay, let's go ahead and verify that they're in there. First command I typically like to do is show running -config. And here it will show us our OSPF routing information. So we have OSPF with the process ID of 10. We have the router ID of 1.1.1.1. We set that correctly. We have the network statement of 192.168.10.0 with a wildcard mask of 0.0.0.255 and area 0. So that looks good for the first network. Second network is 10.1.1.0 with a wildcard of 0.0.0.0.3 in area 0. That one also looks correct. And our third and final network here on R1 is network 10.1.1.4. Now it doesn't look like that's a network address, but if you convert it to the binary, you'll see that the last digits in binary, that host portion is all zeros. That's what makes that a network address, followed by the wildcard mask of 0.0.0.3 with an area of 0. Another command we could use to verify this is our show IP routes. I can hit spacebar to get us done. Now I can go ahead and type show IP route. And we can see that we have our 3 directly connected networks. Here's the directly connected network with its local IP address of the first network, the 10.1.1.0. Here is the other one, the 10.1.1.4 with its local IP address. And then we have the 192.168.0 network with its local address. All 3 of these are configured and directly connected. On to step 2, configure networks for OSPF routing using interface IP addresses and quad zeros. On router 2, configure OSPF using network commands with the IP addresses of the interfaces and quad zero mask. The syntax of the network command is the same as was used above. Okay, so on R2, I'm going to go ahead and click on R2. Log me out. I can log back in. Should be no passwords on it. Get into global configuration mode. So on R2, configure OSPF using network commands with IP addresses of the interfaces and quad zero masks. The syntax of the network command is the same as above. Okay, let's scroll up here to our addressing table. What we have to do is put these addresses in as network statements. And then for the wildcard mask, we have to put in quad zeros. When we do that, that will say this interface is part of OSPF and operating in the area we specify. Okay, so over here in our window for R2, we can get into our OSPF configuration. That is router space OSPF and then our process ID of 10. Go ahead and start entering in our network statements. Start off with network space. I'm going to put in the first IP address, 192.168.20.1. 192.168.20.1. And then the wildcards of 0.0.0.0. Inverse of all 255s is a subnet mask. This wildcard mask of all zeros says we're going to match all 32 bits of that IP address. So we want it to point to a host. We want it to point to that interface. That interface is now going to be part of OSPF. And now we're going to specify what area it belongs to, area 0. Now just go through and add in the other 2 addresses. Network space 10.1.1.10. So that address once again was 10.1.1.10. Wildcard mask of quad zeros and into area 0. Oh, I typed in the wrong IP address. If you type in the wrong address, I did that on the wrong router. I looked at for some reason, I looked at the R3 interface. It should be .2 here. To get rid of this network statement, all you have to do is put the word no at the front of it. Now, instead of typing it all in again, I'm going to use the up arrow. That repeats that last command. And I'm going to left arrow over, type in no and a space, and it removed that command. Now I can go ahead and put in the correct command for 10.1.1.2. Network 10.1.1.2, that address, we want the wildcard of quad 0 so it matches all 32 bits of it and places it into area 0. Last IP address, network space 10.1.1.9 space wildcard of quad 0, so 4 quad zeros. Oh, look at that on my screen. This is another thing that happens sometimes. I got a system update here about OSPF, and for process 10, that's what we're working on. With a root ID on serial 010, we went from loading to full. We are now in full OSPF across this connection. But that system message interrupted me typing. Now, it doesn't do anything. It's just maybe a little confusing to you as you sit there and type and all of a sudden have this message in there. But if you just continue to type and act like it wasn't there, you can go ahead and enter. That's what I'm going to do. So I did get my quad zeros in for my wildcard mask. And then last thing I have to do is specify my area. So area 0, and I can just hit enter. And it processes that entire command just like that system update message never appeared. So I have all 3 of my networks. That's the first one. This is the second one. Oh, that was the wrong one. This is the second one. And then this was the third one right here with the system message in the middle. All 3 of my networks now are listed for R2. R2 has 3 connections in there. We need 3 network statements. Now, it's at least 3 network statements because one of these could be a trunk and have multiple VLANs going across it. So you need at least 3 network statements here. It takes care of step 2. On to step 3. Configure OSPF routing on router interfaces. On R3, configure the required interfaces with OSPF. But first, we get a question. Which interfaces on R3 should be configured with OSPF? Which interfaces here on my R3 router, right here, should be configured with OSPF? Well, we want to make sure that we can route to every one of these networks. So every connection here has a different network to it. Every connection with a different network, we need to advertise that. And so all 3 of these interfaces, we need to set up OSPF on. Now I'm going to click in the window. I'm going to mouse over this green triangle, and it's going to tell me it's serial 0111. So that's the first interface. Serial 0 space 1/1, or serial 0/1/1 is the first one. I'm going to click in this window again, mouse over this triangle. It's going to tell me serial 010. That's my second interface, serial 010. So yeah, serial 010. And then the third interface, I'm going to click in this window again, mouse over the triangle, and that's gig 000 and gig 0/0/0. Those are the 3 interfaces. Configure each interface using the command syntax shown below. Notice we are in the interface configuration, so we have to go into each interface. Each one of these 3 interfaces we have to go into. Then we have to type in IP, OSPF, our process ID. Our process ID is 10, and our area ID is 0. Standard best practice, single area OSPF, use area 0. Let's go ahead and do that. I'm going to go ahead and click on R3. I have to log back in. Enable config T. Now I have to go into each one of those interfaces. I'm going to start off just as I have them listed. So interface space S01/1. Notice our command prompt has changed. We are now in interface configuration mode, and we need to enter in our IP OSPF command to enable routing on the interfaces. So we're in the interface. Now we can go ahead and enter in our command. So it's IP space routing. Sorry, it's not IP routing. It's IP OSPF. Then we have our process ID of 10. And then what area does it belong to? Area 0. This is my preferred method. I'd like to go into the interface and set up my OSPF process ID and area IDs there. That way I know it's set up independent of IP addresses being assigned or networks being used. We can jump into the next interface. So interface space serial 0/1/0. Oh, I got a system update in the middle of that again. I'm just going to enter in that command again. I hit the up arrow, make sure it was right. Serial 010, hit enter. Now I can go ahead and type my command. IP OSPF, our process ID of 10, and it belongs to area 0. I go ahead and hit enter. Now if I wait a second, we're going to get another OSPF system update message saying that we are now full on the interface we just configured. We are now connected into router ID on serial 010. We are in the full communication mode. I'm going to hit enter, change over to our last interface. So interface gig 0/0/0. And let's go ahead and set up OSPF on there. Command once again is IP space OSPF, our process ID of 10, and then area 0. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. On to part 3 of our lab. Part 3 of our lab. Configure passive interfaces. OSPF will send out updates out of all the interfaces on that OSPF router, but it doesn't have to. OSPF updates should only go out interfaces that are connected to devices that will use them. And if we look at our diagram, if we look at R1 right here, R1 should send updates, OSPF updates, out the interface that's connected to R2 and the interface that's connected to R3. Because those are OSPF devices, they'll actually use those. Going to our local area network, there's no devices there that's going to use OSPF, so we should turn those into a passive interface. We have a question. The question here reads, which interfaces on R1, R2, and R3 are the LAN interfaces? Looking at our topology, that would be these going off to the LAN here. If I click in the window here and then mouse over the green triangle, it's going to say it's gig 000 on R1. Let's go down and look at R2. Oops, got to look at the right triangle. Oh, that's also gig 000. And let's go ahead and look at LAN 3, that connection right there. This connection shows gig 000. So all three of these were gig 000 for our LAN connection. That's our answer. G 0/0/0 on all three routers. Configure the OSPF process on each of the 3 routers with passive interface commands. Okay, looking here, the command here is we're in our routing OSPF configuration, and then we say passive interface, and then we give it the interface number. Let's go ahead and start on R1. R1 we got logged out on. Go ahead and hit enter, type enable to log back in, or get into privileged exec mode, config T into global configuration mode. Then to get into editing our routing process for OSPF, we type in router space OSPF and then our process ID of 10. We now making changes to it. This is where we go ahead and set up our passive interface. Command once again is passive dash interface, and then we put the actual interface in there, and once again the interface is gig000. So G0/0/0. That takes care of R1. Let's go ahead and do R2. I think we're still in our router configuration. I'm just going to go ahead and type exit because I'm not 100% sure. Now I can go ahead and type in router OSPF and then our process ID of 10, making sure I'm in the right spot. Here we can go ahead and type in passive dash interface and then give it the interface number, which was gig000. So G0/0/0. That takes care of the passive interface on R2. And let's go ahead and do that on R3. I'm just going to type exit and re-enter in router space OSPF 10 to make sure I'm in the right spot. Once I know I'm there, I can go ahead and type in passive dash interface and then the actual interface again, which was gig000. So G0/0/0. That sets up the passive interface on R3. That takes care of part 3. On to part 4. Verify OSPF. Use the show commands to verify the network and passive interface configuration of OSPF process on each router. We can use the show IP protocols command. I'm going to go ahead and click on R1. Exit twice to get us into privilege exec mode. Now we can go ahead and type in show space IP space protocols and enter. We can see that we do have routing for networks set up. We have our 3 networks that are directly attached to us. We have our passive interface set as gig000. And so we have our networks and interfaces set up correctly. Go ahead and check R2. Type exit twice to get us back to privilege exec mode. And then show IP protocols. On R2, we have the 3 networks that are directly connected to us. That's listed correctly. And we also have our passive interface set as gig000. Finally, go and check R3. R3, type in exit once, exit twice to get us to privilege exec mode, and now show IP protocols. Here we have our passive interfaces set up and running for us. That was Packet Tracer Lab 2.2.13 point-to-point single area OSPF version 2 configuration. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.